So let's have a look today at some qualitative tests we could do for cations or positive ions. So these are the ions we're going to test for. We start with barium, down to calcium, lead, copper. There's 2 copper ions there, and there's 2 iron ions. So when we test for barium, the first test we would do, so our primary test, the first one is going to be our primary test, and the second one will be our secondary test. We're going to do a flame test, and we'll get an apple green flame. That's how we test for barium. Then we want to add sulfate to our solution as well. And if we get a white precipitate of barium sulfate, that means that there's barium in this. That's your confirmation test. And this is the reaction here. These are all basically in this video here, unless otherwise stated, it's aqueous. So it's aqueous sulfate ion, aqueous barium ion gives you barium sulfate solid. Again, it's a net ionic equation. To test for calcium, you flame test, and you get an orange-red flame. And if you add, then to confirm that, you can add carbonate to the solution, and a white precipitate of calcium carbonate will form. So calcium plus the carbonate ion gives you calcium carbonate solid. Now, lead's a different one. If you suspect that lead is in a solution or in a sample, it's probably not appropriate to flame test it. Not ideal anyway, and that's because lead's quite toxic. So if you add iodide to it, an iodide ion, you will get yellow lead iodide precipitate. This is basically lead plus iodide ions. So lead ions plus iodide ions gives you lead iodide. Now you can flame test it, but you should do that in a fume hood. Either of the copper ions, if you flame test it, you'll get a blue-green flame. If you add hydroxide to it, you'll get a deep blue precipitate will form. But if you then add extra hydroxide, it will dissolve away. So that's pretty cool. If you add hydroxide to iron, particularly Fe2+, a white precipitate of FeOH2, so iron hydroxide, so it's actually iron 2 hydroxide will form. This will oxidize to iron 3 hydroxide, though, if it's allowed to sit. So initially it'll be white. If you allow your solution to sit anyway, the iron 2 will oxidize to iron 3, and that can actually lead to a lot of false positives for iron 3. With iron 3, if we add hydroxide, we end up with a red-brown gelatinous, so it's kind of squishy, precipitate of iron 3 oxide. So that's iron, can't spell, oxide. Alright, I hope that made sense. If you have any questions, put them in the comments below, and we'll get back to you as quick as we can. But one other thing before we go, you should also think of this one here as a flowchart. How should you set it out as a flowchart? Alright, see you next time. Bye now.